Once we have completed all the profile, now is the time for us to focus on the drilling operations. So in this video, I will be showing you how to do these 3 holes. I start off with the spot drilling, then peck drilling and counter bore for these 2 holes, and lastly for the tapping hole with the peck drill and tapping. Let's go to the master cam. Okay, let's invisible the 2 path first. I will start off with the spot drilling for these 2 holes. So go to drill, pick this center and this one. Okay, go to the tool. I will create a spot drill, diameter 16. Right click, create tool, spot drill, next 16, click, then next. So this is cutter number 6. Float is 2. Material HSS, calculate. Okay, this is the value. And you go to coolant, on. Okay. Okay, so over here, cycle will be drill, counter bore. Then finished. Okay. Go to cut parameter, should be drill, counter bore. Linking parameter, clearance 50, absolute. Retract is 5, incremental. And for top of stock is 0, absolute. And since this is a spot drill, and you are actually spot drilling for this diameter 6 through hole, so to be exact, if I want to have a spot drill, I must have at least -6 divided by 2. Means that I must at least drill down to -3, absolute. Okay, so this is how you define. If there is a requirement for a chamfer, then what you need to do is from this value, you add in the chamfer that you want. Okay, so for this case, you don't have any chamfer because ultimately your chamfer will be removed by this counter bore. Okay, so I will just leave it as -3. Then click OK. So you can see that this is generated. So I will always go to the front view and change the view to wireframe. Then I go to backplot and I simulate the 2 path. Okay, so of course now I won't be able to see whether this is a chamfer because my purpose of this is just to create a spot. Alright, so for timing wise, I won't check in this case because as I told you before, the timing might be different from you guys. So let's omit the timing at this moment. Right, then I go back to isometric view. So this is for this 2 hole. I invisible the 2 path, and now I will go and create a spot drill for this center hole. So go to the 2 path, drill again, select this center. Okay, tool, spot drill, and cut parameter will be the same. Linking parameter will be start from 0, absolute. And over here, let's go back to the drawing. You require to create a countersunk diameter 7. So to create this, you basically just need to divide by 2. Okay, so just -7 divide by 2. Okay, so this is -3.5. Once you've done, just click OK. And you go to front view and backplot. Okay, you can see that this is generated with the chamfer that you want. If you can't see from here, you can go to the right side view, which is able to see clearer. Yeah, so this is the chamfer. Okay, so once you are okay with this, now we will move on to the next one to create the peck drill for these 2 holes. So I will copy number 8, right click copy, then I visible operation 10. Okay, I'm going to do the peck drilling for these 2 holes, which is diameter 6. Parameter, tool, right click, create tool. So diameter 6 tool is drill, then 6, click on the 6, so updated, click next, This is tool number 8. 2 floats, each SS, calculate. Okay, then now go to colon on. So this is Peck drilling, so cycle should change to Peck drill. Peck is 50%. Finished. Right click, reinitialize. So this will be updated. And now you go to cut parameter, Peck drill, and linking parameter 55, still the same. So the top of stock is 0, and you need to cut down to certain depth. And in this case, it's a true all. So true all is this thickness is 17. Okay, so you are to calculate what is the minimum depth that you need to cut to. So let's say I put 17 down first. Then I usually, using the calculator to let me have some guide. So I calculate, I add in the depth here, which is the tip here. So I add in, it's become close to 19. So if I would like to drill the whole thing successfully, I must have at least 19. Okay, so in order to make sure that this is true all, so I will add in another 2 mm or 3 mm. So in this case, I just add in 2 mm. I will put 21. Then click OK, regenerate. So right click, front view, and you should simulate it and check whether it is cut to true. So now it's true all. Okay, so whether do you need to true all the way down to the stock actually is not necessary. Okay, you can just leave it until here, and because later on when we do the finishing for the facing, we will be able to remove it and create it as a true hole. Alright, okay, this is for the counter bore diameter 6 true hole. Now I will go to create this counter bore. Okay, so to create this counter bore, if you look at the drawing, this is actually diameter 10. I'm able to use the same diameter 10 end mill to create the counter bore. The depth is 6 mm. Okay, so how will I do it? I will copy this, paste. Okay, let me invisible number 10 first. So I just make sure 11 is being invisible. Okay, so I will go to parameter and change the cutter to T5. Okay, T5. And in this case, I will be able to cut the diameter 10 counter bore at 1, right? Then I go to the cut parameter. Okay, of course, if you look at the definition drill counter bore, this is one of the way that we can cut. But unfortunately, the depth that we are having today is 6 mm depth. Okay, so if 6 mm, it will be overstrained for the cutters if you continuously ask the cutter to plunge into the material. So in this case, I will change the technique today by using Peck drill. So Peck drill, what does it do is it will do a packing instead of continuously drilling into the workpiece. So for the packing, I can command it as 2 mm. I can just override here. 2 mm means that after 2 mm, it will pack, 2 mm pack, 2 mm pack. Okay, so in this case, the cutter will at least have some time to fit into the workpiece. Okay, then for linking parameter, and in this case, very clearly, the depth should be -6. Then click OK and regen. So go to the back plot. You should see the cutter is cut to the -6 that we want, and same to this side. Alright. Okay, so that is for how you create the counter bore. Of course, this is one of the way that we can do for counter bore. There are also other way, like for example, pocketing. You can also using pocketing to create this hole or enlarging this hole. Right, so you will be doing this one when you do the caster bracket. Okay, right, so invisible these two paths, and now I will going to do the Peck drill and the tapping for this center hole. I will be copying number 9. Okay, right click, copy and paste, and visible. Make sure this is the correct one. Okay, right. I do have a question asking me what is the depth of this Peck drill. I know that I want to drill 4.5, but I don't know the depth. Okay, in fact, if you found that the drawing doesn't give you any depth that you require for the Peck drilling. Okay, what you can do is you can go to Home and using the Analyze Distance to measure the distance as well. Of course, if you can also, based on your own knowledge, and calculate what is the Peck drill depth that is required if I want to have a tapping which is to the depth of 10 mm. Okay, so everything works well, but of course today if I were to be exact on the timing, I will be doing the Analyze Distance. So I will go to Home, click on the Analyze Distance. I will measure from the top surface here to the flat. Okay, I rotate and let you see clearly to the flat here. So this information giving me is 12. Okay, so to pack this to 12, then click OK. Now let's go to the parameter. Okay, we will first to create a new cutter which is diameter 4.5. So right click, create to, drill, next, 4.5. Okay, choose this. Next, 4.5 is number 7, so it's correct. 2 flutes, HSS, calculate. Okay, coolant, on, okay. And this is Peck drill, so change the Peck to 50%. Finished. Right click, reinitialize. Now you go to this, should be updated. Linking parameter. Okay, remember just now we have calculated the depth is 12. This is where we are going to change. The depth is -12. But this -12 does not include the conical strip at this bottom. So same thing, I will use the calculator to help me to do this calculation. So make sure this is 4.5 and to add into the depth is -1.35 something. So just click OK. So this is the final value that you're supposed to use for the blind hole. Click OK and regenerate. Okay, so I move to the right side view so that you can see whether it is cut to the distance that you want or not. Okay, so you can see that now it is cutting down to the depth that is required. So that is for the Peck drill. Okay, with this, I can proceed to the next one, which is tapping. So right click, copy, and paste. So for the tapping, it is M6 times 1 and tap to 10 mm. So for this case, the 10 mm, in fact, we take it as is included the leading angle. So we will tap down to 10 mm instead. Okay, so go to here, I go to parameter and create a new tapping tool. Right click, create tool, tap, next, M6. So choose times 1, so everything updated. Next, 9. So in this case, I will still using back the same 300. Do not click the calculation. This is 200. Alright. So then this is HSS and coolant on. Okay. So for the cycle, it is rigid tapping cycle. Finished. Right click, reinitialized. Then go to the cut parameter, should be updated as rigid tapping cycle. Linking parameter, for this case, the depth is -10. Okay. And regenerate. Okay. Okay, you can go to the back plot. And check the path. So this is -10, so everything is good. Click OK, change back to isometric view. Okay, so for this, you can change your view back to the shaded. And I would like to do a simulation. So click the two-part group 1, everything, and go to selected operations and run the entire program. Alright, so this is done with all the required dimension and the holes. So now you can close this and remember to save the file. So we will move to the next video to show you how to do the second side facing.